Today, you guys are going to finish up your final week 3 workbook, where you will do the last couple cases analyzing the average earnings of men and women over the last 30-ish years, going all the way up until 2003. I'm just going to do a quick video on case 3. I know this one can be a little more challenging. Hopefully you already did case 1 and 2 yesterday, so then I'm going to help you guys out with case 3. You guys can either click on the link on case 3 to go to the Desmos, or go back to that slide earlier in the workbook where I have all 4 links in one slide. But boom, for this one, we know we have male earnings is on the x-axis, female earnings are on the y. So now I'm going to go type in my line of best fit, y1 squiggle mx1 plus b. Remembering that squiggle, guys, is right above the tab in the top left corner of your screen. You have to hold shift and then that button above tab. So we're going to go put in our line of best fit to see what the patterns look like. Y1, squiggle, shift, the button above tab, mx1 plus b, and boom, we have our line of best fit. Okay. So we have our m and our b that we'll eventually need for our slope, but the first thing you guys need is a screenshot. So you guys should hopefully be getting in the habit of the screenshots. Hold down Control and Shift with your left hand. Tap that button above the number 6 with your right hand. Take all your hands off, and you should be able to draw a nice perfect box. And please make sure to include the y-axis and the x-axis. And I'm going to include myself, but you won't have that problem. And then we will come back, and you guys we'll just go down and hit copy to clipboard and then Control V into yours. But boom, resize it so you have your nice graph and scatter plot so we can see it. And now we'll go and type in our equation for the line of best fit, where it's always mx and then the b at the end. So we'll go, I see the m is 0.908. We just have to use the first couple, guys. So since that's an 8, I'm going to round this up to 0.91. So 0.91x, your m is always what goes with x, and then plus or minus b. In this case, it's negative, so we'll go minus 6,049. Minus 6,049. Boom. Now, we will interpret the trend and the specific slope in a complete sentence using our good old sentence stem up here. And remember, guys, when we interpret the slope, we're just going to use that number that's with x. We are going to completely ignore that y-intercept at the end. So our sentence is only going to include the m, the slope that's with x. So we're going to say as the x variable increases, the y variable will increase or decrease. I first see that going from left to right, the line is going up, so I know that's an increase. I see that my slope is positive. That's another way for us to know it's increase. So in this case, guys, the x variable is over the average male earnings. So I'll say as the average male earnings increases, the y variable this time, the y variable this time is over the average female earnings. So as the average male earnings increases, the average female earnings increase. Specifically, the y variable, and we're going to say the same thing that we did up here. Whatever, if we chose increases or decreases here, we'll choose the same option here. So specifically, the y variable, so the y variable still over average female earnings. The average female earnings increase by whatever your slope number is. So I go up and look at what number is with x. So by 91 cents, because 0.91, so less than $1, every time the x variable increases by 1. So every time the x variable, so the average male earnings increases by $1. So what this is saying is that as male earnings increase, so do female earnings, but not as fast. Specifically, the average female earnings increase by 91 cents every time males earn another dollar. So then we can start seeing that gender pay gap, where women are only getting 91 cents to every dollar increase that males get. And then you guys will be able to go make a prediction. According to the model, if a man is making $60,000, how much would a woman be making in a similar job? So this number, if a man is making $60,000, goes with X, because X this time is how much the men are making. And then the Y will be females. So when we go to our graph, guys, we're going to click on the line. And the first number is going to be the X, the average male earnings. The second number will be the females, the Y, how much they're earning. So when I go over here and click on it, that first number is how much men are earning. The second number is how much females are earning. So I can't even go up high enough for that first number to get to 60,000. So I'm going to zoom out a couple times so I have the space. Then I'm going to scroll until that first number represents the men of 60,000. Get as close as you can. It's okay if it's not exact. And so what this says, guys, boom. Oh, wow, I got it. So the first number is X. That is when men are making $60,000. That number next to it is how much the model would predict women would be making at $48,452. $48,452. Just had to remember that, and now I'll make that into a full sentence. According to the model, when men make $60,000, women would be making $48,452. So then we can use the model to make a prediction sort of going into the future. And then you guys will do that same exact math for case 4 in your workbook. And make sure that you guys finish up all the cases. You guys should be doing all cases 1 through 4 by tomorrow.